Before to talk about Explainable AI, I would like to thank the invitation to do this presentation. So this is the agenda for the presentation. First, we will do like a summary of machine learning and big data. Then I will explain what is Explainable AI, why we need it, how we can solve it, some examples, and then about responsible AI and the future. So let's start with machine learning. Machine learning is a subfield of AI, and of course deep learning is a class of machine learning. So when we say AI and machine learning, it's like saying the egg and the yolk. Please don't do that. So why we have deep learning? Well, deep learning is neural networks. That's not really old. But now we can have many layers because we have more data, big data, and more processing power, things like GPUs and other chips that are tailored to train neural networks. And with that, then we can have supervised models. This will be a generic example, not necessarily for deep learning, because in deep learning the feature vectors are basically found by the system. But here we have labels that are attached to images or text or whatever objects we are using, and then we train a model, and then we use it for new objects. And of course, as these are predictions, we have to cross our fingers that the expected level will be the correct one. And this can be used for many different things. So we can not only predict, but also we can prescribe, so try to do things before they happen. And that means truly data-driven decisions. In most cases, we have a small data, and there we have a bias to big data, so we also need to work on big data solutions. Small data solutions, not only big data. So what about big data and predictability? So we have the complexity of the problem and the size of the problem. So let's say I want to train a classifier to predict my face and then transform it to my name. This is not too difficult. We don't need much data. But the truth is that we only have changed the representation from an image to a word because the system doesn't really know who I am and what I mean. We can have something like Einstein's formula, and of course that applies to every object in the world, so we can say that that's kind of big data. We can try to predict the stock market, but that's much harder. So that problem is really complex, and doesn't matter how much data you put, you will not improve, because basically people is not rational. And we may try to, for example, predict all the animals in the famous picture painting by Bosch, The Garden of Delights. And here will be very hard to predict all animals, because if we use normal animals, that will fail, because these animals are very weird. So we need a special training process, and maybe we will not have so many paintings like this to be able to predict this well. So what is Explainable AI? So Explainable AI is replacing a black box, and this was defined in the DARPA program of the US government in 2016, such that we can answer this question. Why did the AI system do that? Why didn't do something else? Why succeeded? Why failed? Do we have enough confidence? Or is that an error? So instead of having what we have today, that basically we have a decision or recommendation and the user cannot ask this question, we will have an explainable model with an explanation interface where we can understand why or why not, why succeed or why fail, why I need to trust the system, or why I think it error. Now, why we need Explainable AI? So one first reason is to verify the system for transparency. Another reason is to improve the system. For example, mismatch objectives or trade-offs in a multi-objective system. Or for sensitivity purposes. Some systems are very sensitive. For example, here we have the 1 pixel attack. So we just change 1 pixel in these images and the system changes from, for example, cat to bird, cat to dog, ship to airplane, car to airplane. So we really don't know what the system is learning. Maybe it's not learning an animal, it's learning something else. Also, we can learn from causality, and causality is very important. Or we need to explain to be compliant legally, for example, for safety or for privacy, data privacy, like GDPR, the Privacy Directive of the European Union. We will talk later about this. We can have this for ethical reasons. Again, transparency or fairness. Why discriminated women? Why discriminated some race? And it's very easy to learn to be, for example, racist from data. This is another example from the US, who will be the typical example, is from England and Wales. You see that if you're black, you have 3 times more chances to be arrested, and then you have 50% more chances to go to prison. So the system is not fair. We have the same problem in the web. You can check my article that I published 2 years ago in Communications of ICM. But basically, we have a vicious cycle where you have bias in the data, bias in the samples, bias in the algorithms, bias in the interaction, where you have the cognitive biases of the users interacting with the biases of the algorithm. And then you have second-order bias, which is how these people use the data to put more data on the web, or how systems use the behavior of people to do, for example, personalization. And of course, not all people do the same in the web. You have participation bias, and basically this is like the minimal effort law. But this explanation may help us in the future. For example, the police may ask, does your car have any idea why my car pulled it over? And then the car may answer, oh, we know, we are speeding, please give the chauffeur a ticket and don't waste our time. That will be a very honest car. And then we can have accountability, right? Who will be accountable? And then if the AI system should be accountable, then we need to ask the question if AI systems have rights. Well, remember that legal entities today are individuals, corporations, and in some countries, even idols. And this is important with climate change. For example, a river in China has a legal entity. So the answer is no. We are the masters, systems shouldn't have rights. So then who should be accountable? Well, should be the person that prepared the data, should be the people that labeled the data, should be the people that did the training, should be the people that put the system in production, or should be the people that were in charge of the user experience? All of them. Maybe not. Maybe the company that sells the system, right? And we'll get back to that. So, Joanna Bryson, last year, did a very interesting article about explaining AI systems. So, for example, one possible choice is, okay, we don't have explanations, it's too hard, it's impossible. Or we need to explain the human actions that led to the system. Like, this is good for accountability, for better understanding of the system. We can explain what inputs resulted in what outputs, to be able to experiment with a black box, for example. Or for legal reasons, to record this information. Or seeing exactly how the system works, an exploration of the overall system, and also will help to do machine learning models more transparent. In many cases, the first one is not reasonable. We need to do explanations. For example, the first one. In the third case, yes, when people is involved, when people can be harmed. This is very important. Well, do we always need explainable AI? Of course not. It will depend. For example, in many cases the system don't have significant consequences to merit explanations, like advertising in the web or postal code sorting in the mail. In other cases, the problem is very well studied and validated in real applications that we have to trust the system decision. Moreover, if that works in real time, for example, aircraft collision systems in an airport. So the question is, the challenge, which systems can or should be fully automated? And then this is the explanation framework already explained. We have an explainable model and explanation interface. But we have a person, a human in the loop that will check the decision. But what about if we don't have this person? Then we have what is called an automatic decision-making system. And we need to remember that these are predictions. These are not the truth. So in this case, we need to have contestability. We need to have one way that the person affected by this system can complain. And this is already happening. For example, early this year, in France, there was a case of facial recognition in a high school. And they look at the competence, at the consent of users, and at the proportionality of the actions. And at the end, they had to take the system out. Or for example, very recently, several drivers doing an action in the Netherlands against Uber because an algorithm decided that they have been cheating in the system and the drivers didn't agree. We'll see what happens in that case. And we have many challenges in the data analytics part, in the autonomy part, to learn a model, to explain decisions, and to use the explanation. Here we have an explanation example. So for example, this is a system to recognize cats, and the current explanation is just saying it's a cat. But a better explanation here is on the right. It has fur, whiskers, and claws, and it has this feature, pointing ears. Maybe it doesn't know how to say pointing ears, but can show a scheme of what the system means. And there are many ways to approach the problem. For example, we can be comprehensible, we can be interpretable. We don't want to be opaque. And then the question is, should we include reasoning, like in a factory? For example, the image has halogen lights, a concrete floor, and so on, so the system can really explain what it's looking at. But the explanation might be difficult. For example, what is this? Most systems will fail at this image. And you're surely not, because humans are very good. So this is a cat looking from below a glass table. But many times systems are afraid to say, I don't know. If they're not confident, systems should say, I don't know. And remember, to abstract, you need to forget. So we learned that the cat sideways is not the same as a cat in a different position because we can abstract the cat. Otherwise, it will be like Funes de Memorius, this famous story from Borges, a person that couldn't forget. So if you had the bad luck to say, Funes, how was your morning? Funes would take 3 or 4 hours to tell the whole morning because he couldn't forget. So if it's a cat, and the system can say that this is a cat, how the explanation will work, because it doesn't have pointing ears. So interpretability does not imply completeness. And of course, the explanation may come from the data, the model, the process, from anywhere. Maybe we can even make up a story like Hinton said in an interview, but still we need to do explanations. And of course, we have a trade-off between accuracy and explainability. For example, decision trees are easier to explain, but you have a better accuracy with deep learning, and of course, those are harder to explain. Here there are some two possibilities to explain deep learning models. There was a survey by Samek et al. In 2017 on this. Here you have two different ways to do it, using propagation or using sensitivity analysis. But one problem with the system is that you need to know what's inside the black box. So we need to know that it's deep learning. What about if we don't even know that? Well, we need a model agnostic explanation. This is one of the solutions that was proposed 4 years ago, which is called LIME. There are others. And basically it's treating the black box like an object of experimentation. So for example, here we can do experiments to learn this dashed line that separates two types of results. For example, if this is the original image, which is a dog with a person behind and the dog is with a shirt, which is something hard to explain. So here are the explanations for an electric guitar, for acoustic guitar, or for the dog. But this may not work. For example, this is a typical example where a husky is classified as a wolf because the system learned that if there is snow in the background, then it's a wolf. Clearly, there were not enough images of huskies, and that's what the system learned. And then we need to evaluate the explanations. And of course, more specific the evaluation, more costly because we need to have real humans involved on this. In 2018, there was another interesting paper on explaining explanations, and this has to do with interpretability and completeness. So, for example, interpretability is very important for GDPR. We will talk about that. And completeness is very important to explain what was wrong and to make sure that we're not making decisions for the wrong reasons. So they have a taxonomy where they use visual cues, individual units, or attention-based mechanisms that have to be related to completeness and interpretability. So visual cues explains the processing of the data, the individual units explain the representation, and the attention-based part explains the explanation. And of course, the first one is about completeness to the model, the second is about completeness on other tasks, and the third one is about the human evaluation. And they propose a taxonomy and best practices where they mention which methods and which kind of evaluation we need to use for the processing part, for the representation part, or for the explanation producing part. So in the Article 22 of GDPR, it says very clearly we need to be able to contest the decision in the case of a mistake. Now, this is the actual text of the article, but what that text says for most people? Well, if we want to know if the data processing falls under Article 22, we need to give individuals information about the processing. So at least we need interpretability. But if people have the right to contest and challenge the decision, you will need to explain. And this means that it's not something static, that every time the system is retrained, you need to verify that the system still works as intended. And this implies legal and ethical issues, ethical codes for developers, for companies, maybe even for robots, like the laws of Asimov. Can we have international consensus? Can China, Russia, and the US have an agreement on what is the ethics of AI? Who knows? There are many moral dilemmas. There are many factors involved. Even we may need to prove explanations. In 2017, the US Technology Policy Committee did a statement on the 7 properties that algorithms should fulfill to be transparent and accountable. And here is the list. I will not read it, but we may need not only explanation, but things like data provenance. Can we follow the data, like in organic food? Even, can we have awareness, so the system knows what it's doing and is aware of the biases of what it's doing? And we need to remember that the system doesn't have to be perfect. We just need to be better than humans. For example, self-driving cars will kill some people, but of course will be much less than people because they will not drink alcohol, they will not look at the cell phone, they will not get distracted, they will not get sleepy, they will not get hungry, and so on and so on. So some bad human practices, and I will not read all of them, but for example, human bias, correlation instead of causality, reusing code in the wrong context, not wanting people to check your solution because it's a trade secret, conflict of interest, not measuring the impact of the deployed system, too much personalization affecting privacy, using the wrong data. By the Murphy law, the data you have is not the data that you need. And remember, you cannot learn something that is not in your data. So some recommendations designed for people first. Respect the limitations, especially the ethical risks. Usually we are behind ethics until something wrong happens. Enforce the code of ethics. Improve explainability. Evaluation. Remember, we are in control. We are the masters. So the machines are in the loop, not the humans are in the loop. We are the masters. So what is the future? I'm not really worried about artificial intelligence. I'm really worried about natural intelligence. And every election in the world shows a little bit of that. But sometimes we have good news. We need to remember, for example, with this quote of Harari, that we are the masters, and then the problems of artificial intelligence are the problems that we create. Because if we are not careful, this may happen. Prove that you are not a human, ask the system, and the robot says there are no more humans. The system says correct, and they both laugh. Not because the robots kill all the humans, because the humans kill themselves. So to finish, we will have more integration. Maybe we have no privacy. This false dichotomy between privacy and health, we're already seeing it by COVID and contact tracing apps. We should have explainable and transparent algorithms. Otherwise, insurance companies will take over and we will have insurance for training data, insurance for models, and so on. And then developing this kind of software will be much more expensive because we didn't do our job. Ethics for robots, surely. We need some laws like Asimov laws. We need to have knowledge workers. Someone will need to train these machines. That means that we need to have teachers that are better than machines. So we need very, very good masters to teach machines. Augmented humanity, I hope not. That will create only more inequality in the world. So again, quoting Harari, either democracy will reinvent itself or will live in digital dictatorships. And we have already seen a little bit of this with fake news and similar content in the web. Still, I'm optimist. I think that technology is improving the well-being of most people. But are we evolving towards Solaria? If you like science fiction, this was a world where people lived apart without having a real society. Or we need nice aliens like Arrival, so we are forced to talk to each other and not having all this difference between different governments, religions, politics. So I have time for questions. Thank you. And also even I can have biased questions or explanations. Thank you.